Hey everyone, it's Canfield. I figured I was gonna go and do the L'Hopital's homework, and I was like, I'll just do it on camera. Um, so I'll probably scan this and throw it up on the internet too after I'm done. So the first question, 1299, says the limit as x goes to 0 of e to the x over x, and so it says L'Hopital, so my gut reaction is to use L'Hopital's rule. However, I need to double check direct substitution first. Can I just directly substitute in? Let's see, e to the 0 is 1 over 0. No, it's failure. However, I can't use L'Hopital's because L'Hopital says 0 over 0 or infinite over infinite. So because of that, we're stuck. So if we think about this as x approaches 0, well, we know that e to the x, this is a function that's always defined, and x is approaching 0 on the bottom. That's a problem because division by 0 is a problem. And so this is going to wind up being some kind of asymptotic behavior. And if I were to think about this with a little sign test, like, okay, I know 0 is an issue. What about like -1, or what about 1? If I plugged in e to the x over x, let's see, if I plug in -1, I'm getting a positive on top and then negative on the bottom. So that seems like it's going off to negative infinity on this side. So it's like swooping down like this. We've got an asymptote. And then from the right-hand side, they're both positive. So because of that, it's swooping up to positive infinity. And so we'd say that limit does not exist. Let's see, we'll move on to 1300. It says the limit as x approaches infinity of e to the forks over 5x. So we can't directly substitute because infinity is not a number, but let's think about it. That's going to be e to the infinity over 5 times infinity, which is just infinity over infinity. L'Hopital, there he is. Okay. So if I were to do L'Hopital's rule, that says we can take the derivative of the top and bottom separately, meaning don't do any of the rules that we're used to with like quotient rule or anything. Just take the derivative of the top. So the derivative of the top is e to the 4x. It just stays the same. And then the derivative of the derivative of the exponent pops out in front. So we get 4 e to the 4x. The derivative of the 5x is just 5. So now if we were to plug infinity in again, we'd get infinity over 5, which is just going to be infinity, or does not exist. All right, 13.0. A little French for you there. Let's see, if I was really going to say French, 1301 would be what is it? 10,000 ayants? I don't know. Okay. All right, let's do the old plugaroo. I can look at this and see it's going to be infinity squared over e to the infinity. Okay, so it's infinity over infinity again. So we can use L'Hopital's rule. And if anybody remembers from class, I have a tendency to forget to write the limit thingy every time. But just remember that we're taking this limit, and when we get infinity over infinity or 0 over 0, that we are then able to go back in and say, oh, okay, if I take the derivative of the top and bottom, the limit is the same. The function's not the same, everything else isn't the same, but the limit of the two is the same. So the bottom's going to turn into 3e to the 3x, and the top is going to turn into 2 times x plus 5 to the 1. And this runs into the first thing that we didn't really talk about in class. This is still infinity over infinity. But there's nothing that says I can't just do L'Hopital's rule again. So now when I take the derivative of the top, I get 2. And then the bottom is going to be 9 e to the 3x. And so now when I plug in infinity, I get 2 over 9 times infinity. which is 0. All right, 1302. Let's see. All right, so that says the limit as x approaches infinity of e to the 3x minus 2 to the x over 3x. All right, so when we're looking at this one, plug in infinity. Now we wind up getting infinity minus infinity over infinity. So we're not even necessarily sure what the top is doing on its own. Maybe this is going to be better for me to, I'm allowed to do this. I don't know if it's going to be better or not, but I'm going to think about e to the 3x on its own over 3x minus 2 to the x over 3x. So they're both infinity over infinity. So we're able to kind of do these separately. So if I look at this one, I'd get 3e to the 3x over 3, which is going to wind up being infinity. Okay. Ah! All right. Real sounds with Mr. Canfield. So then this one, the second one, if I do L'Hopital's rule, I forgot the limit thing. So here I'd get 2 to the x ln 2 over 3. We're getting infinity minus infinity. This is great. Okay, we haven't talked about how to do these. And this is not something that I would expect you guys to handle. Shoot. Well, shouldn't have assigned that one. But I did not assign the following one after it, so I didn't do 1303. But just for those of you who are curious, let's just check it out really quick. So the limit as x approaches infinity of e to the 3x minus 2 to the x. So actually, my memory is not serving me right now. We have a couple different tactics for what to do with this. I don't want to take up video time on this. So don't worry about 1302. That's more of a Calc 2 issue. So I think 1305 is the next one that we want to care about. So if I look at 1305, there we go, nice simple one. The limit as x goes to 3 of x squared minus 9 over x minus 3. We try plugging it in, we get 0 over 0. So that would lead us to then apply L'Hopital's rule. X goes to 3, we'd get 2x over 1. Plug in the 3, we get 6. There we go. Now we're rolling. 13. Limit as x goes to 2 of the, the natural log of 3 minus x over 1 minus e to the x over 2 minus 1. Gee, that just looks so friendly. Let's try plugging in 2. We get ln of 1. And ln of 1 is 0, and then 1 minus e to the 2 over 2 is 1. All right, so we wind up getting 0 over 1 minus 1, or we get 0 over 0. So now we can go to the hospital. So let's go to the hospital and drop stuff in. So let's see, the derivative of the top, limit as x goes to 2. The derivative of the top is 1 over 3 minus x, sorry. And the derivative of the bottom, the 1 goes away. The negative e to the x over 2 minus 1 is all still there. Then times the derivative of the top thing, which is just a half. So it's going to be negative a half e to the x minus 1. Which at first glance is like, it's awful. Plug in the 2. We get 1 over 3 minus 2. Then we get negative a half e to the 1 minus 1. So 1 over 1 all over negative a half times 1. So we're dividing by negative a half. So it's negative 2. Shoot. Oh, that's what I did wrong. Okay, so I did something wrong a little bit earlier on. I did this problem with somebody earlier today, and I'm like, that's the wrong answer. We're really close. I made a mistake when I took the derivative of the natural log of 3 minus x. Sure, it's 1 over 3 minus x. But then you have to remember that we got chain rule, and chain rule still happens. So it's got to be this times -1. So it's really a negative out here. There's a negative, and so it changes it to a +2 in the end. That blue highlighter is not very visible on the screen. In real life, it's like popping off the page. Let's see, 1307. This is a good one. The reason I didn't say the last one was a good one is because it took forever. This one is very nice. Let's see, we plug in 0, we get sine of 0 over 0, so 0 over 0. Great. So now if we take the derivative of the top, we're going to get 3 cosine 3x there. I remember to do chain rule that time. Over 2. And hey, let's take the limit as x goes to 0 of that. We'll plug in 0. We get 3 times 1 over 2, which is just 3/2. Sweet. 1308. 1308 is going to be similar. It says the limit as x goes to 0 of sine of 8x over 6x. And it's going to work out really similarly. You might be able to jump to the answer if you kind of see how things are going to follow through. It's going to follow the exact same way. We get 0 over 0. Take the derivative of the top and bottom, and we get 8 cosine 8x all over 6, which when we plug in 0 is just 8 over 6, which is 4/3. So let's see, 1309. Limit as x goes to 0 of tangent of 3x over 2x. All right, so similarly, we're going to get 0 over 0, so we can take the derivative. That's a 0, Canfield, not an infinity. All right, so that's going to be 3, then secant squared 3x all over 2. You might not be familiar with this. Remember, secant is the flip of cosine. So when we plug in 0, well, the flip of cosine at 0, well, cosine's 1, flip 1, it's still 1. Square it, it's still 1. So it's 3/2. 1310. Limit as x goes to ℆2. 1 minus sine x. Sorry, I got ahead of myself. Started writing the pi there. Then x minus pi over 2. So the top, 1 minus, well, sine of pi over 2 is 1, so 1 minus 1 is 0. We get 0 over 0 again. Great. So then the limit is x goes to pi over 2. We'll get negative cosine x over 1. Now when we plug in our pi over 2, cosine of pi over 2 is 0. We just get 0. Hooray! All right, 1311. All right, the limit as x approaches 1 of 3x squared minus 5x plus 2 all over x minus 1. So plugging 1 on the bottom, I get 0. Plugging 1 on the top, we get 3 times 1 is 3, minus 5 times 1 is 5, so 3 minus 5, negative 2 plus 2. Oh, cool, we get 0 over 0. So then we can take the derivative of the top and the bottom, plug in the 1, get 6 minus 5, and get 1. 1312. Sweet. All right. 1312. I'm not going to use L'Hopital's rule personally, but I'll show L'Hopital's rule and that it still works. All right. So I see this problem and I go, okay. Oh, but I'm still on the screen. I haven't been looking as closely as I normally do. Okay. As we fly off to infinity, it's a horizontal asymptote. What's the horizontal asymptote? Well, if you remember your rules or how this works, since x squared's the biggest power, I've really got like 3 infinities on the top, and it just beats out everything else, and it's infinity over nothing. It just goes off to infinity. So I already know the limit of this is infinity. But if I were to try plugging in infinities, I get 3 times infinity squared minus 5 times infinity plus 2 over infinity minus 1. It's infinity over infinity. If we L'Hopital it, we get 6x minus 5 over 1. Plug in infinity there. 6 infinities, take away 5. That's basically nothing. No, just kidding. 6 infinities minus 5 is still infinity. So it's infinity. Or, you know, the good old Dine. All right, and we said we're skipping 13 all the way up through, let's see. Oh yeah, I said try the last few. So I'll show these. These ones are pretty neat. Pretty neat. I can't remember if I told you to do 1322 or not. So I'll just bop 1322 out real quick. X squared e to the negative x. Well, yeah, looking at that the way it is, it's like, I don't know. But if we were to rearrange this, that's just x squared over e to the x. Plug in your infinities, it's infinity over infinity. Sweet, I can use L'Hopital's rule. So its limit as x goes to infinity of 2x over e to the x. Hey, it's still infinity over infinity. Do L'Hopital's again. What? All right, so we'll do L'Hopital's again. Get 2 over e to the x. Now it's 2 over infinity, so it's 0. All right. 1323. All right, hold on. I think I might have gone too fast. So 2 over e to the x, that's 2 over infinity. So remember, a number divided by something infinitely large, we're going forever, so it approaches 0. There is no number you will ever plug in here and actually get 0. We're just going there. All right. 1323, the limit as x goes to infinity, nice and simple. Wait a minute. Excuse me? The limit of an integral. What? All right, so I figured I'd throw these in there just to have you think about it a little bit. So let's see what happens. First, we got to calculate this integral. Well, remember the way we calculate an integral is we look at this. This is t to the negative 1 or 1 over t. So if we were going to do the add power thing, it wouldn't work. That's because the antiderivative of 1 over t is the natural log. So the natural log of the absolute value of t evaluated from x to 2x. And that's going to be equal to the natural log of the absolute value of 2x minus the natural log of the absolute value of x. Just plugging it in, right? So now that we have that, there's a couple ways for us to handle this. The thing that I'm going to do is I see it's one natural log minus another natural log. So using our log rules, I was using cursive and all of a sudden I switched. Hold on, let me switch back to cursive. All right. We can write it as the top divided by the bottom, right? 2x, the first divided by the second. 2x divided by x. If we do that, that means our x's are going to cancel out. And it turns out to be just the natural log of 2 without any x's. And the absolute value bars are there, but the absolute value 2 is just 2, so it's the natural log of 2. So, if I go back to the problem and say the limit as x goes to infinity of the natural log of 2, last time I checked, if I keep on making x bigger and bigger and bigger and bigger and bigger, but there's no x, it's just whatever number's there, that means that the answer to this is just the natural log of 2. Strange result. $13.24. All right. So I'm going to hijack a little bit of my work from 23 into 24. Oh, I can't. Oh, I shouldn't have assigned this one. You guys don't know the integral of natural log. So we can't do this one yet. Sorry. Oh, I wish I'd done that on camera. I just took this and I was trying to put the cap back on, and I was like, I missed. I'm not tired, you're tired. All right, let's look at the next one. Let's see, it says 1325. Limit as x equals to 0 of cosine x minus 1 e to the x minus x minus 1. Also, hello, Mrs. Canfield, if you are watching, because I know that you were watching the video I uploaded yesterday. I love you very much. All right. Let's see. So if I plug in 0, I get 0 on the top, and e to the 0 is 1, so that's 0. Okay, so we get 0 over 0. We're good. So we can do L'Hopital's rule. So we can get the limit as x goes to 0 of negative 6 over e to the x minus 1. All right. So now it's still 0 over 0. Strange. So we can use L'Hopital's rule again. Get the limit as x goes to 0 of negative cosine of x. Let's see, negative cosine of x over e to the x. And you might be like, oh, I'm going to get 0 over 0 again. No, you don't. If we plug in 0 this time, we get negative 1, because cosine of 0 is 1 with a negative out front, and e to the 0 is 1. We get negative 1 over 1. We get negative 1. We get an actual number. And then 1326, our last one. Limit as x goes to infinity of e to the x plus x squared over e to the x minus x. All right, let's see what happens. First, we will plug in infinity and get infinity over infinity. Wow, I'm surprised. We'll take the derivative. We'll get the limit as x approaches infinity of e to the x plus 2x over e to the x minus 1. Oh, drat. I have to do it again, so we'll do it again. Get the limit as x goes to infinity of e to the x plus 2 over e to the x. I still get infinity over infinity. No! Let's see. Equals the limit as x goes to infinity of e to the x over e to the... Wait a minute. E to the x over e to the x is 1. So now I'm just asking for the limit as x goes to infinity of 1, which is just 1. Okay. So I feel bad about a couple of those questions being on there, but I wanted to record me going through the homework just because we hadn't talked about multiple applications of L'Hopital's rule. Hopefully you saw how simple it was, though, that, oh, we did it once, just do it again. But if that was helpful, great. Leave a like or whatever, or don't. Actually, just don't. Bye. Or I'm not hitting the stop button now. I'm just pushing my phone. Let's try this again.